find the relative maximum on the function f of x is equal to 2x to the 5th over 5 plus 8x squared over 2. Justify your answer. So when we're talking about looking for a relative maximum, a couple things need to happen. If a relative maximum is going to occur, it's going to happen if the first derivative is equal to 0 or the first derivative does not exist. Since we have a polynomial here, well, once we calculate it, we'll look at our derivative. We will end up with a polynomial, so we don't have to worry about it not existing, but it does have to at least equal 0. And then the other thing we need is we need a sign change from positive to negative on that derivative. So let's first find the first derivative, f prime of x, and just using our power rule, we're going to end up here with 2x to the 4th plus 8x. And again, polynomial, so we don't have to worry about it not existing, but we do have to worry about when it's equal to 0. So we'll set our derivative equal to 0 and factor out anything if possible. It looks like we can factor a 2x out of this. So we pull a 2x out, and that leaves us with x cubed plus 4. If we set each of these factors equal to 0, we're going to get 2x equals 0 and x cubed plus 4 equals 0. This gives us a possibility of x equals 0 or x equals, this is where it gets a little ugly, the cube root of negative 4. So these are our two possibilities for where a relative maximum can exist. To test for the sign change, we want to look at a number line for f prime. And on this number line, we're going to put down the cube root of negative 4, and we'll put down 0. We're looking for a sign change from positive to negative. Now, to fill in this for sign changes, choose a value that's somewhere in between these. So, for instance, if I'm going to choose a value bigger than 0, maybe I just choose 1. I plug it into the derivative. If I plug in 1 into the derivative 2x to the 4th plus 8x, that's definitely going to be positive. So I'll mark that as positive. Between 0 and the cube root of negative 4, let's try negative 1. And when I plug in negative 1, I'm going to get a negative answer. If I plug in something much less than the cube root of negative 4, let's say negative 2, negative 3, something like that, it will end up giving me a positive value back. And so right around this critical value, the cube root of negative 4, we've got a sign change from positive to negative, which is what we need. So we can say that there is a relative max at x is equal to the cube root of negative 4, because f prime of x equals 0, and there is a sign change from positive to negative.